Welcome to the Putty Math Teacher. We're going to start with expectations. Make sure you use twice this video's length to take notes, ask questions, answer questions, explain to those around you. Make sure you understand it as we're going through it. Use your notes to answer the comprehension questions at the end. And again, you can pause, rewatch, change playback speed as desired, whatever helps you take notes and focus the most on this video. And then use my website to also find more resources. All right, moving into the notes. So again, we're doing operations with rational numbers today. So actually, I'm going to minimize this again and go over our objective. So objective, we're going to add, subtract, multiply, and divide rational numbers. So we're going to go over rational numbers really quick at the beginning of what is a rational number. We'll go over mixed numbers and proper fractions, and then we'll do 4 examples. So it's going to go really quick. So make sure for page 2 you have operations with rational numbers already labeled and headed up. And again, I'm going to write with a marker as we go through this. So we're going to start with, actually I'm going to use a pen for this. That way it's smaller. So in the top margin, we're going to start with writing out fractions and repeating and terminating decimals. So farted, if you want the acronym. So this is all of rational numbers. What are they? So rational numbers are fractions, and then all fractions can be written as a repeating or terminating decimal. So for example, like 2/3, that would be a repeating decimal. So it goes 0.666666, and it goes on for forever. And so that pattern is just the 6. So you could write it with just the bar over the 6. That's your pattern. There are rational numbers that repeat with an actual pattern more than just one number. So like 0, 1, 0, 1, 0, 1. So the bar goes over the whole pattern that repeats. Another one would be like 1/4. This is terminating. It stops at 0.25, 25 hundredths. There's nothing beyond the 5 except for zeros, and so this would be a terminating decimal. All of these are rational numbers. We're going to focus on the fractions aspect today, but I just wanted to note what other numbers could be considered rational. All right, so we are going to start with the least common multiple. So least is going to mean the smallest. Common is something that is the same. In this case, we're going to talk about 2 different numbers, what they have in common. So that means they both have this in common. And then a multiple is a number multiplied by an integer. And I didn't go over it much in the last video, but an integer is a whole number, so 0, 1, 2, 3, 4, but also all the negatives of those. So also -1, -2, -3, -4. So least common multiple, and we're going to do some examples. So we're going to have 3 examples. First one will be 4 and 8. What was its least common multiple? Second example will be 7 and 6, its least common multiple. And then our third example will be between 4 and 10, knowing their least common multiple. So I have 3 examples. 4 and 8. So a multiple of 4 would be 4 times 1, 1 being the integer, 4 times 2, 4 times 3, 4 times 4. Those are all 4 being multiplied by an integer. So I have 4, 8, 12, 16, and so on. 8 would be 8, 16, 24, and then 32, and so on. But they have something in common. They have several things in common actually, but what's the smallest multiple they have in common? Ooh, I have a reminder for tomorrow. Okay, so hopefully that'll go away. I don't know. Oh, it's on my phone, isn't it? There we go. I got it. All right, so the smallest number they have in common would be 8. That's a multiple they have in common. 4 is not what they have in common. 4 is a common factor, but 8 is a common multiple. Factors are multiplied up to a number, so they're smaller than that number. Multiples are usually larger than that number, but they could be equal because you always have that times 1 that makes a multiple. 7 and 6. will actually be 42. Think about why it is 42. Why isn't it something smaller? And then 4 and 10, pause the video, figure it out on your own. It's 20. They have 40 in common, but the least common multiple will be 20. And we're going to use this. So we're going to use the least common multiple to find common denominators. Now we're going to use this for just the addition and subtraction, not the multiplication and division. You could use it for multiplication and division, but it's going to make your life harder because you're going to have 2 extra steps that are not necessary, and you're going to have to work with a lot larger numbers. So we're going to use this just for addition and subtraction. And then I also want to go over mixed numbers. Improper fractions are more convenient. So in order to move a mixed number into an improper fraction, let's think about what this means. So this means I have 4 wholes with 3/8 left over. So I'm going to have 4 candy bars that are whole, and then I'm going to have 3/8. So I'm going to divide this into eighths. I think I did that. Nope, there we go. 1, 2, 3, 4. There we go. I'm going to use my pen so we can see a little better. Okay, so I have 4 holes. So that's 1 whole candy bar, 2 whole candy bars, 3 whole candy bars, 4 whole candy bars, and then I have 3/8 left over as a remainder. But I want this in improper fraction. Improper fractions are all over the same denominator, so I need to know how many eighths in total I have. I could count these up, but there is a mathematical way of figuring it out. I have here 4 groups of 8. So to figure out how many parts there are, I'm going to multiply 4 groups of 8, and then I'm going to add the extra 3 that I have. So I'm going to have 8 multiplied by 4, add 3. This is still over the same denominator because they're all being measured into eighths. So I'm going to end up with 35 eighths. So that would be how we're going to work our improper fractions. You can always draw a picture if that helps, but we're going to move on quickly to our examples, trying to get this nice and short. So these 2 examples in this column will need common denominators, and these do not need common denominators. All right, and we're going to then draw this into 4 boxes, and we're going to have 4 examples. So this will be our adding example. We're going to add 1/7 with 3/5. This will be our subtracting example. It will be 1/8 minus 1/4, and then I'll do multiplying and dividing next. But we're going to work with just our addition and subtraction first. So notice I'm using horizontal fraction bars. I'm not using the slashes. This keeps my numerators and denominators separate, and I need to make their denominators common. So what's their least common multiple? 35. So I need to make this fraction, this 1/7, look like something over 35, and the 3/5 also look like something over 35. But I can't just multiply by 5 in the denominator without also doing it in the numerator. So when I multiply by 5, it has to be 5 over 5, because what's 5 divided by 5? 1. And fractions are just division. So this is 1 times 1/7. That means I'm not changing the number, I'm just making it look different. I could simplify this 5/35 back down into 1/7. And this 3/5 I'm going to multiply by 7 divided by 7, a convenient name for 1. And then 3 times 7 is 21. Add my numerators, and I'm going to get 26 over 35. That's as simple as it gets, so that's my answer. Make some notes. Add more things to this if you need to. Figure out what steps I did in what order. Make notes to your future self. You may understand it now, but this is to tell you in the future what you're supposed to be doing. Okay? So now for subtraction, again, I need to make a common denominator. We already did this actually. It's 8. So I'm going to need this over 8 and this one over 8. Well, we already have 1/8, so I don't have to do anything with that one, which that's really nice. The 1/4, I'm going to multiply by 2 over 2, because that makes 1. 2 divided by 2 makes 1. 2 times 1 makes 2. 1 minus 2 is, so notice I'm doing the subtraction in my numerators together, and that's going to give me a negative 1/8. So that's my final answer. All right, and then multiplication and division. So multiplication, we're going to do 2 different ways. Multiply, and we're going to do 2/3. Again, I'm using parentheses for multiplication. I'm not using an X, and then division will be 2/3 divided by 15/14. So these examples will look really similar, but for this first one, I'm going to do it 2 different ways. One on the left-hand side, one on the right-hand side. You can choose to simplify it different parts. So we could go ahead and multiply the numerators and multiply the denominators. Notice that numerators still stay at the top, denominators still stay at the bottom, but I multiply them by each other. 2 times 15, because of the clock, I know this is 30. 3 times 10 plus 3 times 4, so 30 plus 12 is 42. And now I need to figure out what they have in common. So this is factors, not multiples. So what's a number that goes into 30 and 42? Preferably the largest number. So they have 1 in common, they have 3, they have 2, and they have 6. 6 is their largest common factor, greatest common factor. So I'm going to divide by 6 in the numerator and denominator. Again, notice we're doing it on both numerator and denominator. So I'm dividing by a convenient name for 1, and I'll end up with 5/7 as my final answer. So I simplified at the end, and 30 and 42 were larger numbers I had to deal with. The second way of doing it is I can simplify at the beginning. So to simplify, you always need 1 numerator and 1 denominator. So 2 and 3, that's 1 numerator and 1 denominator. Do they have anything in common? Any factors other than 1? No. Having 1 in common is nice, but it doesn't help me with anything. What about 15 and 14? Do they have any common factors other than 1? No. But I can pair up opposite numerators and denominators, so 2 and 14, do they have a common factor other than 1? Yes, they have 2. So what's 2 divided by 2? 1. Notice how I cross that 2 off and I put a 1 next to it. I'm no longer using that 2, I'm looking at just the 1, and this 14 changes to a 7. Pause the video. How did I do that? 15 and 3, same thing. That goes to 5, that goes to a 1. Now when I multiply my numerators and my denominators, I end up with 5/7. I did that just for space's sake, but I should leave it like this. This is much prettier, much better of an answer. I have 5/7 as my final answer. So I'm dealing with smaller numbers because I took the beginning numbers and simplify them to make them smaller, versus this first method, I made them larger and then simplified. So it's up to you if you like to simplify at the end like we did first, or at the beginning like we did second. And there went my markers. All right, so for division, trying to speed us along here, get us done before 15 minutes. Division. You can go online, figure out different things. I would say think about pizza. If you have 2/3 of a pizza and you're dividing it amongst 5 people, what are you really doing? How many pieces do you end up with? And then what does it mean to take 2/3 divided by 1/5? This means that 2/3 will become 1/5 of whatever your new number is. And what's that going to necessitate you to do? So think about these 2 examples and what you'd actually do. What's a picture that would represent it? And now we're going to move into this. We are going to multiply by the reciprocal. So what you're going to find with these 2 examples is you'd always be multiplying by the reciprocal. So I'm going to take this 2/3, change it to multiplication instead of division, and then flip the 15/14. The 14 is my new numerator, and the 15 is my new denominator. Again, I want to simplify if possible. I need 1 numerator and 1 denominator. 2 and 3, nothing in common. 14, 15, nothing in common other than 1, but that doesn't help us. 2 and 15, 14, 3, nah. This is as simple as it gets. So once I get my answer of 28/45, I know I'm golden. I'm done. Woohoo! So pause the video, think about as much as you can why this works. How does division make sense? And then think about these questions. So pause the video, think about these questions. We went over some of them, and then see if you can think of further questions that you could wonder about this and how you could apply it to the real world. Have a great day, and thanks for watching.